The second category of issues is coordination. Remember that we have heterogeneous distributed application, multiple things going on at the same time. And these multiple things have to synchronize across certain actions. Okay? And how is that going to be provided? The two main categories of synchronization are synchronous applications, synchronous communications, and asynchronous communications. Synchronous means that when one piece of the application initiates that particular message or interaction, that it waits until it gets a reply back, a response back, before continuing. Often synchronous types of interactions are clocked. That means there's some heartbeat or other measure of when it can do certain things. On the other hand, asynchronous communication means the client can continue to execute after it's sent the message, and it's notified when the response comes back, and it can take appropriate steps at that point. Obviously, asynchronous is more general, but writing code for dealing with asynchronous coordination is a little trickier, makes it a little harder to understand. So once again, there's a trade-off. Another question with respect to coordination is who's in charge here? Okay, is it the client or the server? You've no doubt seen situations where the server is capable of pushing things out to the client, such as web pages which want to update with current events. Or it could be that the client requests information, that is, it pulls from the server. Deciding how you're going to deal with that is a key design question in any distributed application. It's always the case with such applications that robustness is important. What this means is that the system can deal with situations where one or more of its components goes down. Think that you send out a message and you don't get any response back. And the reason you don't get any response back is that the piece of the application you were dealing with goes down. How does your part of the application deal with that? Think, for example, if you're user-facing, you don't want to just wait there and leave the user in limbo. You want to provide perhaps some timeout on the message acknowledgement and be able to let the user know what went on. Similar to robustness is availability. How does the system appear to the user as far as being available? Is it a 24/7 type application? Does it have set maintenance times? How does it deal with load situations? That is, does it get so slow that the user gets frustrated? All those kinds of questions. Persistence, we've already mentioned. In general, this means how is server state maintained? One obvious approach is with a database. It might be a file system, but nevertheless, the choice has to be made. And if you've got multiple clients talking to the system, how is that concurrency handled? Okay, how does the server part of the application deal with all these multiple users? Related to that is the transaction and integrity constraints which we talked about on the previous issue.